All right, when I was a kid, my dad drove a truck, or he still drives a truck, but uh, that's why I'm a math teacher, because he told me to stay away from a truck. He makes way more money than I do. But anyway, it doesn't matter. Grade, angle of elevation, and angle of depression, all stuff he used as a truck driver, which seems kind of crazy, but it's true. Uh, some complicated math involved in that stuff. Not that it's complicated, you just need to learn it. So here's the sign that I saw one time when I was riding with him when we went across Wolf Creek Pass. A sign like this, I should say. We have them kind of all over the United States. We got a 6% grade versus an 18% grade. And what do those two signs mean? And this is a trigonometry problem, which, believe it or not, kind of I think they're very interesting problems. But grade is typically this. Typically, it is this. So you have this right triangle. There's the right angle. There's our theta. And we're in this semi-truck driving up this 6% grade. Well, what that means is for every 6 feet of rise, or 6 meters of rise, if you don't like the English measurement system, doesn't matter, we would go 100 feet of horizontal distance. So 6%, just to kind of help you out there, goes back to, what does a percent mean? 6% means 6 divided by 100. Percent means per century. Percent, 100 divided by 100. Per means divide. So that is telling you literally that you're going to drive up 6 feet for every 100 feet you drive on the horizontal distance. Now, I'll be honest with you. This 18%, so you're going to, for every 100 feet, you're going to drive up 18 feet. I've been on a slope like this in a truck, and to be honest, I would rather get out and walk than to ride with my father on one of these grades. They're not bad, and they're all over the U.S., but they do feel very, very steep when you're in them, especially when you're hauling a 60-foot trailer. And so again, we've got this theta here, and for every 18 feet of vertical rise, you travel 100 feet of horizontal distance. So what are we really dealing with in this case? And what's nice about it is that's the slope. 6% grade is rise of 6. You remember this, rise over run in both cases. 18 is your rise, 100 is your run, 6 is your rise, 100 is your run. And what is so cool about this, if you think about tangent theta, this is opposite, this is adjacent. That's the TOA in SOHCAHTOA. And so we're dealing with tangent here. So tangent theta in this 18% grade is equal to 18 over 100. Opposite over adjacent. And so we can find that angle. So we can go into Google here. This is, again, double check to make sure we're in degrees. You can do radians if you understand that, but if you don't understand it, these videos are typically for people who are just now getting introduced to these concepts. So we're going to be dealing with degrees. And I'll clear this thing out. And we want that 18%, which is 18 over 100, which would be 0.18, and is tangent. So we could find, if we use the inverse and the arctangent, or inverse tangent, whoops, better do it in the right order. So inverse arctan 0.18, whoops, not 188. There we go. Close that up. So that is the angle. So this is a 10.2 degree angle of elevation. So that truck is traveling at a 10.2 degree angle. Okay, on the 6% grade, same thing. It's tangent theta equals 0.6 or 0.06, 6 over 100. Maybe it's just better to do that. And again, the same thing. So the inverse tangent, so inverse tangent, arctan, 0.06, close your parentheses, and that's 3.4 degrees. Doesn't seem real scary. And honestly, 10 degrees doesn't seem real scary. But I guarantee you, if you go out in the mountains and you are on a 10-degree slope, you will feel like you are crawling up almost a vertical ride, almost a straight up and down cliff. It is crazy what your mind does to you when you see a 10 degree change. And the thing is, each of these thetas are called angle of elevation. Elevation in both cases. Which brings us to our next set of terms, angle of elevation and angle of depression. So, let's say you're an airplane flying at 30,000 feet and can see the airport runway at an angle of depression of 3 degrees to the runway. How far away from the runway is the airplane in horizontal distance? So here's my attempt at artistry. There's my airplane. And so this airplane is flying along the horizontal. So here's the ground. I'll draw it solid. Maybe I should draw it in green so it looks like the ground and blue is the sky. They're flying parallel to each other. And here is my runway, the start of my runway anyway. There might be some guy up there looking up at the plane. And the guy in the plane's looking down at the runway. This angle is the angle of depression. Right there. Oops, that's an N. So that's the angle of depression. Think of it as the guy in the airplane looking down. Okay, he's 30,000 feet above the ground. So there's 30,000. And the angle of depression was 3 degrees. So that means your angle of elevation, which is this one, is also 3 degrees. So the guy on the ground looking up is going to see the same angle as the guy in the airplane looking down. And that's because of a property called alternate interiors of parallel lines. The guy flying the plane, hopefully, is flying parallel to the ground before he starts to descend. And so they're parallel to each other, so their angle of depression and angle of elevation are equal. And that is alternate interior angles, if you remember your parallel angle theorems. Excuse me. So what we want to find in here is this horizontal distance, x in this case. And so what's cool about this is we can just use SOHCAHTOA. So the 30,000 feet, if you go from 3 degrees here, the angle of elevation, that is opposite. And we're trying to find x, which is adjacent. So we're going to use tangent. So tangent of 3 degrees equals 30,000 over x. And then it's just a matter of solving that. So tangent 3 times x is x tangent 3 using cross multiplication, because you can put that over 1. So I did tangent 3 times x. 1 times 30,000 is 30,000. Then you would divide both sides by tangent of 3. And x equals 30,000 divided by the tangent of 3. So we're ready to plug this baby into a calculator. Here's our calculator, 30,000. Whoops, I didn't get the marker in the tray. Let me get rid of that. So 30,000, there it is, divided by tangent of 3 degrees. Close the parentheses. Make sure we're in degrees here. There's radians, there's degrees. We're good to go. And so we're 57,000 or 572,000 feet from the runway. Well, a mile is 5,280. So we'll divide that by 5,280, and we're 108 miles from the runway. And there we go. So we are approximately 108 miles away. Kind of a long distance away yet. But that gives you an idea of angle of elevation. Now there's one more problem we can do here. I've got one more queued up. And this one's more local. I've done this a lot with my students. The top of a water tower is 200 feet away. So you got this water tower that's 200 feet away, not the top of it, but just the water tower itself from you to the water tower, 200 feet away. Has an angle of elevation of 42 degrees. How tall is the water tower? So see if you can draw this picture. Hit pause, try to draw it, try to solve it. See if you can figure it out yourself. Because if you know SOHCAHTOA, and you can kind of imagine this tower 200 feet away from you, see if you can make this thing work. Alright, so here's what it looks like. So here's our tower, our water tower. Okay, we are 200 feet away from it, and we'll just assume that it's to the center of the water tower. And we can look at the center of the water tower to the top, and our angle of elevation is 42 degrees. And the height of the water tower we'll call x. So there's our picture. X is opposite, 200 is adjacent, hypotenuse is over here. We don't really care about it because we have everything we need with opposite and adjacent and the 42 degree angle. And again, SOHCAHTOA, we're using tangent. So tangent 42 degrees equals x over 200. Tangent of 42 is over 1, cross multiply. So 200 tangent 42 equals x. So all we need to do is take the tangent of 42 times 200. So let's just do that. 200 times tangent 42 degrees equals 180 feet. So this tower, or this water tower, whatever it is 180 feet tall. And there you have it, or 180.1, however you want to do that. Not 180 degrees, sorry. So 180 feet is the height of that tower. And I've had, when I've worked for lots of people, they've asked me to do this for them. You know, how tall is my advertising sign, so that we can get somebody out here to work on it? How big of a ladder do we need? Things like that. How tall is that tree? Is it going to hit the house if we cut it down? These are kind of useful things you can use with trigonometry. So I hope this helps. See you next time. Have a good one.